Hello, my name is Mahant and today I'm going to be talking about my project GoWiki. So GoWiki is a simple web application created using Go for the backend and React for the frontend. It is very similar to Quantum Magazine as it allows you to create and view science articles from a wide range of topics such as math, science, physics, as well as computer science. For any web application, it needs to have a frontend and a backend. And here my frontend was written in React.js and it is under the client directory, and my backend written in the Go language is under the server directory, which represents the backend code. For any Go file, it starts off with a package declaration, and in this case my package is main. Next, I'm going to be declaring my imports, which is context, which allows you to define the context of the situation, like when iterating to an array of MongoDB documents. Next is going to be encoding/JSON, which allows you to encode and decode JSON documents in the JSON format to the local language format that the language is able to recognize. And the FMT package allows you to format and store formatted strings. The io/ioutil package allows you to read and write files from the file system. Log allows you to log errors as well as report results into the console. Net/HTTP allows you to handle HTTP requests and responses, and it's very useful for web APIs. OS is a package that allows you to perform operating system low-level operations, and it also allows you to get environment variables, which is why we are going to be using it in this case. The time package allows you to define the time period for an action, and in this case I'm going to be using it to limit the request to my API to 60 requests per second, which prevents it from malpractices as well as DDoS attacks. The next two imports, which is bson and bson/primitive, those define the primitive data types found in a MongoDB database, and bson stands for binary JSON, which is the format that MongoDB uses. And the final two imports are Mongo and Mongo/options, which is similar to Mongoose in JS because it allows an interface with the database, which is MongoDB. I'm going to be moving on. I'm going to define my article struct, which contains an ID, which is of type primitive.objectID. The next field would be title string, body string, image string, and auto string. And you can notice that all of them are encoded in the JSON format. If I had not defined this import, then this code would show an error, as you can see here. VS Code automatically imports this particular package as it needs it for the JSON formatting. And I defined my database URI to be an SRV URI of MongoDB plus SRV and Mahant, which is my name. And then I get the credential from a file, which I've defined here. Function get credential string, which this particular get credential function, returns a result of type string. So result comma error equals ioutil.read file credentials.txt, and these contains the credentials for my particular MongoDB database. And here you can see that the read file, the ioutil.read file method, file name string, returns two variables. I have a variable of type byte, type array byte, and an error. And this is what I'm defining here. There are two variables which are the values are being unpacked into two variables, and the res value contains the byte variable, and the error and the error variable contains the error. And if error is not equivalent to nil, which means that an error exists, then you're going to print the error fmt.println error and then os.exit 1. It calls os.exit. And then I'm going to return the string representation of this particular result as it's in the byte format. I'm going to be converting it into a string and appending it to the MongoDB URL. Then I define my database to be GoWiki, my collection to be articles, and war collection star mongo.collection where I'm defining the mongo.collection from the mongo driver package that I have imported above. Next, I'm going to be moving on to the initialization function, which contains the initialization for the database. Client options equals options.client with apply URL database URL. Client comma error equals mongo.connect context.todo. Client options. I'm feeding the client options into this particular function as a parameter, which is mongo.connect, and it asks for the client options, which is what I'm feeding here as an interface. And if error is not equivalent to nil, the same error handling is done. And I log the error and call os.exit with a one response code. Then I say if it's not creating an error, then I say that database connection successful and I log it. And I say collection equals client.database, my database dot collection, my collection. And I say created a collection because I have initialized the collection. So there are four important methods here: create article, get all articles, delete article, and that's it. So I'm going to be going through each one of these methods in detail. So the create article method allows you to create an article using an API request. And this API request sends a request to the API, which is the code described in this file. And it calls the MongoDB database and it appends the document to that particular collection. Function create article w_http.response_writer r*http.request. So r*http.request is a pointer to the struct, star is a pointer to the struct http.request, and it contains 16 different fields that describes a request. The most important fields are the method request, the URL string, and the origin of the request. So I'm going to set the headers to be equivalent to context type application/JSON. This is pretty self-explanatory because you want to return a response of type JSON. The next thing I do is set the access control allow origin to star because I want my API to be accessed from anywhere, although it's not a very good practice in enterprise web development. It is very important to secure your API, which is why I have created my rate limiter, which I'm going to be talking about later. And I've set the method to be equivalent to post, as I do not want any other method. Like you send a get request and you get an error code and the API crashes. I do not want that. So I have specifically set the method allowed to be equivalent to post. Finally, I have set the access control allow headers to be equivalent to content type. I have defined an instance of the article called as var new article equals article. Null identifier equals json.new decoder r.body.decode person new article. Here, I am referring to the new article using a pointer percent and I'm decoding the body into the new article. insert result, comma, error equals collection dot insert one. I'm inserting just one document into the MongoDB database. And I'm using the context dot background. I'm using the context of the situation. And the document to be added is the new article. I'm going to hover over the insert one method. And it says document interface. And this will be my interface, which is new article. If error is not equal to nil, again log the error. It's pretty self-explanatory. And it says log.println insert result. And if it's a success, then it's going to be equivalent to 0. If it's a failure, it's going to be equivalent to 1. Then I say json.new encoder http.response writer dot encode new article. It encodes into a JSON document and sends it as a JSON response. Similarly, the next function gets all the articles, treats every document in the database and returns it as a result to be rendered by the frontend. The last function I'm going to be covering is the delete article function, and this is used to delete the article or a document from the MongoDB database using the document's ID. Then I define a router called as mux.router because I have multiple API routes. And here I say I just need the post request for API/create and allow the get request for API/read and only allow the delete route for API/delete. And any other route that sends requests to this particular route will receive an error code. And then I define my main function as a runner to this particular code. I say r equals router, which refers to this router function. And this is called the Walrus Operator, which allows you to define variables without explicitly declaring them. You don't need to say something like var r star mux star router, and then you don't need to define it using this function. You could directly use the Walrus Operator to simplify your coding experience. Then I say fmt.println server running on port 8080 to tell the user that the port is 8080. Then I get the port variable, and if port is equivalent to null, set the port to 8080. And then I say log.fatal http.listen and serve. It listens to the port and then it serves. And then I have the semicolon plus the port, which is just another way of saying localhost colon 8080. And I'm going to add my rate limiter function, which I'm going to be discussing right now. Here is my rate limiter function. Let me just read out the description that I have created. A limiter that has a ceiling of a maximum of 60 requests per minute, which is equivalent to 1 second per request or 1 request per second. And my bucket size would be 3 requests per second, and it will be queued because I want the user to send a maximum of 60 requests per minute, which means 1 request per second. And it seems like a reasonable amount because it wouldn't cause a server overload and will not be prone to DDoS attacks. And I can also queue my requests in order to not allow any more requests to occur if it exceeds the limit 3 requests. Var limiter equals rate.newLimiter rate.every time.second, 3. Here you can see it's every time.second, and it creates an instance of a limiter called as rate.newLimiter, and it's defined by the bucket size 3 and a function rate limit http.handler http.handler returns a type http.handler. Return http.handler function w http.response writer r star http. If limiter allows equals false, then you send the response code for the 2